boys and girls, how are you all? क्या हाल चाल है जनता? Welcome to an amazing course that we are having for those bachas going from 10 to 11th. Okay, so before that, let me just give you a quick introduction. I am Gaurang Sir and I am physics master teacher at Vedantu. I have done my graduation in BArch from IIT Roorkee and I have been teaching from last 10 years. And in these last 10 years, I have mentored more than 12,000 students, including top 10 AIRs like 2 and 3. Okay. So without wasting much time, let's move on to our sessions. Shuru kare janta. Okay, once more, how's the Josh? Aye sir, that's the spirit. So, actually the course that we are starting is bridge course. Okay, now first of all let me tell you what exactly is this bridge course. Now see, what actually happens is till 9th and 10th your syllabus is quite restricted. Okay, you must have seen your books, physics, chemistry, maths, very thin books I believe. Okay, and if any of you has already seen the 11th class books, this is the normal size of the books. And then on that it is written in bold letters, this is part 1 of physics. Okay, so what actually happens is when you go from 10th to 11th, syllabus increases many folds. Secondly, the topics are a mix jumbled. Okay, like the topic that we are talking about right now is vectors. Vectors in actuality it is for the maths. Okay, but what happens is in physics we have to use it right from the start. So for that purpose we have started this bridge course. In bridge course what I'll be teaching you is only the specific part of vectors that is helpful for physics. Okay, we are very smart, we are not going to learn the entire vectors. Let's leave something for the maths teachers also. Okay, so what we'll be learning is only that part of vectors that is required in physics. Okay, so let's start with vectors. Now, before talking about vector quantities, let's discuss about an important quantity called what are physical quantities. Okay, guys, there's a difference between maths and physics. In maths, we calculate the quantities. In physics, we measure the quantities. Okay, so any quantity that we can measure is called physical quantity. Okay, everyone clear with me? Everyone following me? So example for these, you have already studied length, mass, velocity, temperature, and so on and so forth. These all are measurable quantities, means you can actually measure them. You can take an inch tape, this is 6 feet 2 inch, this is 1 inch, or this is 5 centimeters. Now guys, did you see something important in all these terms that we were talking about? Okay, let's say, okay, let me elaborate it a bit. Let's say I ask you the distance of your home from your school. Is it sufficient to say it is 5? Okay, what's the distance of your home from your school? So 5. Is 5 sufficient in itself? Not at all. Why? Because immediately I will ask, bhai 5 kya? 5 kilometers, 5 meters. Okay, some unit is necessary. So any physical quantity that we talk of, it has a numerical value. Okay, and apart from that, there should be some unit. Got it, guys? Okay, so this is a physical quantity which are all measurable. Okay, so 5 kilometers, this in itself will be a physical quantity. So now we are clear with what exactly is a physical quantity. It should contain some numerical value as well as a unit. Okay, now let's go further deep into it. what is the classification of physical quantities. Okay, now physical quantities are classified in two ways, scalars and vectors. Now what are these? Let me explain that by a very simple example, shall we? Let's say you ask me, what is the distance between Delhi and Mumbai? Let's say we are talking about air to air distance. So what is the distance between Delhi and Mumbai? What I will answer is, it is 1200 kilometers. Guys, it might or might not be correct. I'm just giving it a fluke. So you asked the question, distance between Delhi and Mumbai. I replied 1200 kilometers. The question is complete. You are satisfied. Now just imagine you are a pilot and you are supposed to fly a plane from Delhi to Mumbai. Okay, you just took off from Delhi and you asked the air traffic controller, sir, I want to go Delhi. And the reply you got was, you do one thing, just travel for 1200 kilometers. What will be your reaction like? भाई क्या बोल रहा है? Exactly. ठीक है? Why? Because you'll say, sir, 1200 kilometers में I might reach Afghanistan, I might reach China, or I might reach West Bengal. Okay. Is replying travel for 1200 kilometers sufficient? Not at all. What you will expect, sir, kis taraf? That is the first question you will ask. Now air traffic controller will realize his mistake. हाँ यार, blunder हो गया ये तो. Then he will say, okay, do one thing. Travel for 1200 kilometers in, let's say, southwest direction. This is southwest, I guess. Yeah, it's southwest. Okay, and he might specify you some angle also. Okay, or let's say for keeping the question easy, he just replied, go for 1200 kilometers in the southwest direction. Now that information is sufficient for you. Okay, it's not visible here. Let me use black. Now you are going, you took off from Delhi. You will go going 1200 kilometers towards southwest and safely reaching Mumbai. Now, did you find any difference between the two quantities? First question, distance between Delhi and Mumbai 1200 kilometers, complete. Second case, only distance was not sufficient. What you require was the direction as well. So now, boys and girls, you yourself have identified the difference between scalar and vector. Getting my point? How? First quantity that I mentioned was scalar quantity, classification wise. A scalar quantity is a quantity that has only magnitude. Magnitude means, what was the example we took off? 1200 kilometers. Okay. Direction was not at all necessary. So these kinds of quantity are scalar quantities. The example for this, length, or you can call it distance, volume, time, mass, work, energy. Okay, these are all scalar quantities, means they do not require any direction. Got it, guys? Second important difference, a vector quantity. Okay, second type of quantity actually. A vector quantity is that has magnitude as well as direction. Now guys, let me point it out here. Maximum students get confused here that vector quantity means only magnitude and direction. Okay, let me explain this part and then I will explain what the common confusion is. See, magnitude we just discussed in the past example, 1200 kilometers. Direction we just specified, southwest. Okay, there's one more very important component in a vector quantity, and that is it should obey laws of vector addition. Okay, so first condition is they should have magnitude, they should have direction. Apart from this, they should also obey vector laws of addition, and this is the part which most of the students forget about. Okay, almost all of them are clear. So scalar means magnitude, vector means magnitude and direction. Guys, one interesting thing, a quantity may have magnitude, may have direction, but still not be a vector. Okay, don't worry, we'll come into that. Now you must be thinking, sir, confused kar rahe ho aap to. It happens, don't worry, it will get cleared out. Got it, guys? So, example for vector quantities: velocity, force, displacement, acceleration. So as we were mentioning, important components of a vector quantity: it should have a magnitude, it should have a direction, it should have vector law of addition. Now you must be thinking, sir, अगर magnitude and direction है तो vector law तो follow होना ही पड़ेगा. Not necessarily true. Okay, let's see an example. Okay, let's say total mass we are talking about. First example that I take is of total mass. Suppose you are holding a mass of 5 kg. I give you 1 kg more. What will be the total mass you will be holding now? 5 plus 1, 6 kg. Very, very easy. Champu hai to. Okay. Let's say I bring 3 kg more. Now what will be the total mass? Obviously 9 kg, sir. Bahut simple hai. If I take away 4 kg now, the total mass you will be holding is 5 kg. Means what you actually did was you simply added and subtracted. Okay. Why it was possible? Because mass is a scalar quantity. You can simply add and subtract. Now let's take a different example. I am sure every one of you has played carom. Or not carom, you must have played billiards, snooker, pool, whatever. Let's say the striker is here. Okay. You hit it somewhere here. You are going for a trick shot. And let's say it comes here. And for simplicity purpose, let us give some values. It travels for 1 meter here. 1 meter here, and let's say 2 meters here. Okay, it was a huge carom board, suppose. Now if I ask you, what is the total distance traveled by the striker? Then you can easily comment. It will be 4 meters. Very easy. Why? How come you find this? You simply added them. And why this addition was possible? Because distance is a scalar quantity. Getting me, guys? Now the second question, if I ask you, what is the separation between the initial and final position of the striker? Now, although it has traveled 1 plus 1 plus 2, can you simply write that the separation will be 4 meters? Obviously not. Means here direct addition of the terms were not possible. Why? Because what actually we are asking about is displacement. Okay, this term we'll be learning a lot, using a lot in the coming chapters. Initial and final position, the separation between them is called displacement. And since displacement is a vector quantity, okay, you cannot simply add all the components. You will have to take into direction into consideration as well. Getting it, guys? Kuch chamak raha hai? Everyone following? Okay, very good, guys. Great going. Now as we were discussing, okay sir, magnitude clear हो गया, direction भी clear हो गया, but how can a quantity have both but still not be a vector? Let's have an example. I am sure all of you has learned Kirchhoff's law in your 10th class. Remember something called Kirchhoff junction law. Okay, and what was it? Here, if 5 ampere current is entering a junction and 5 ampere is entering from here, we simply write the current leaving the junction will be 10 ampere. Now if we talk of current, it is obviously having a magnitude. As you can see, the magnitude is 5 amperes. It is having a direction as well, but still we do not consider current as a vector quantity. Okay, current is not a vector. Why is it so? Because it does not follow vector laws of addition. You are still algebraically adding or subtracting them. Okay, let me give you one more example for the same. Suppose I tell you that 3 ampere current is coming from here, 2 ampere current is coming from here, 1 ampere current is leaving. Find the unknown current. Okay. Very easily you can solve it. 3 plus 2 will be 5. 5 ampere current is net entering. Out of that, 1 ampere is leaving from here. So the current here will be 4 ampere. Okay. Now, can you realize what you actually did? You were simply adding or subtracting algebraically. It does not matter if the 2 ampere wire was like this or like this. Had the 2 ampere wire be something tilted like this, the result would be still the same. Okay, because in current we perform algebraic subtraction or addition. Direction is there, but that direction does not affect the scalar addition. Got it, guys? Everyone with me? Chamak raha hai sabhi ko? That's great, guys. Lovely. So the common examples we already discussed. For scalar and vector, scalar we have distance, mass, energy, charge you will learn, speed. Okay. Vector we have displacement, velocity, force, velocity, acceleration. All these quantities are vectors. Guys, there are huge chart of scalar and vector quantities. We are just discussing a small portion of them. Those quantities which we'll be using very frequently. Okay, got it, guys? Now, in fact, one more interesting thing, let me tell you. Scalar and vector are very close. Okay, how come? If you say a bike is going with a speed of, or bike is traveling with 60 kilometers per hour. Okay, if you specify only this, it actually becomes speed, which is a scalar. But if you say the bike is traveling with 60 kilometers per hour towards north, as soon as you specify the direction here, it becomes a velocity. And velocity means it is a vector quantity. Okay, so scalar and vectors are very closely associated. Okay, it just depends on how much information you're giving, whether it's a scalar or a vector. Everyone following, guys? Chamka sabhi ko? Very good. Now, notation of a vector. Okay, we all understood what exactly is a vector quantity, but how do we define it or how do we represent it? In pictorial form, the very simple representation of vector is an arrow. Okay, let's study about this in further. See, this is the arrow. Now there are two important things here. First of all, the length of this arrow represents magnitude. Okay, means if I draw vector this and I draw a vector of half the length, since the length is half, we will conclude that the second vector is half the magnitude of the first vector. First point. Second, in a pictorial representation, there are two important terms. One is the tail of the vector from which it is starting. Other is the head of the vector at which there is the arrowhead. Got it, guys? So the direction of vector is from tail to head, something like this. You can see it in the video. Getting it? Any confusion up till now? I hope not. Very good. Now this was how we represented it pictorially. Second is how do we write it in equation. If we want to show that a quantity is a vector quantity, we simply represent it like this. A, and I wanted to show that it is a vector quantity, I will draw an arrow on this, on the top of it. It is called as a vector. Okay. Now guys, many students get confused that, sir, if the vector is suppose like this, so shall we draw the arrow also like this? Or suppose if the vector is like this, so the arrow should be like this. No guys, a vector is always represented like this. The arrow on the top does not represent the direction, it only denotes that a is a vector quantity. Okay, so don't get confused. Many times students draw like this or like this. Don't make such blunders. Got it? Like suppose it's a displacement represented by S, so we draw S vector. If it's velocity represented by V, we draw V vector. Getting it, guys? Everyone following? Very good. Next we have is a magnitude. As we discussed earlier, a vector in itself is a physical quantity. Physical quantity means it has a magnitude and it has a direction. So if I write a vector, its magnitude is represented by like this. Mod of a vector. Okay, it will be like this. Okay, this mod represents only the magnitude part. Means like let's say if you're writing 1200 kilometers southwest. So if we talk of the magnitude will only be 1200 kilometers. It is represented by mod A. Everyone following, guys? Chamka? That's nice. Very good. Now another important topic that we are landing upon is types of vectors. See guys, there are loads and loads of vectors. Okay, but we are not going to discuss all of them. As we said, let's leave something for our maths teachers. So we'll be learning only those vectors which are helpful to us or which we'll be using in physics. So the first vector is equal vectors. As you can deduce from the definition itself or from name itself, vectors having the same magnitude and same direction are called equal vectors. Means suppose I am writing a vector equals to b vector. What does it mean? Mod A is equals to mod B, definitely. and both the vectors are in the same direction as well. Means if we want to represent it pictorially, let's say this is our A vector. So for B vector, what you can say? It will be having the same direction, sorry, and the same length of the arrow. Got it, guys? So these are called equal vectors. Very easy to understand, I hope. Second we have is opposite vectors. Now opposite vectors, what does it mean? Again, magnitude is the same, but directions is opposite. So let's understand first in the pictorial form. If this is A vector, this is B vector. Now you can see the length of the arrows are the same, means magnitude is the same, but the directions are opposite. So A and B vector are opposite vectors. Okay. And how do we write it? A vector equals to minus of B vector. Everyone following, guys? चमक रहा है सभी को? That's nice. Now, before going into third type of vector, I have a very important statement regarding movement of vectors. Now, what exactly is the statement? Suppose, guys, this is A vector. Okay. And let's say I moved this vector like this. Okay. Did I change the magnitude? Okay, guys, don't get confused here. Both the vectors are of same length. Okay. So, did I change the length of the arrow? Not at all. Did I change the direction of the arrow? Not at all. That means, did I made any change in the vector quantity? No, not at all. So if I am calling this B vector, A vector is the same as B vector. So what's the statement that I want to tell you? If you shift or move a vector parallel to itself. Okay, observe in the video, guys. Let's say this is a vector A vector. If I move it parallel to itself downwards, did I change the length? No. Did I change the direction? No. So the vector quantity is the same. Everyone following? Again, A vector, A vector, A vector. Now it has changed. Why? Because although the magnitude is the same as before, but now the direction has changed. So this cannot be said as A vector. But yeah, all the remaining ones can be said as A vector. So the statement that I wanted to explain or emphasis upon was, on shifting a vector parallel to itself has no effect on the vector quantity. Okay? Chamka, guys, following everyone? And remember this statement. This statement is very, very helpful in the coming topics. Okay. And now we have a third type of vector with us, that is called coplanar vectors. Now coplanar, I am sure you might be able to deduce from the word itself, coplanar. What does coplanar means? Very easy. If vectors lie in the same plane, then, oh sorry, it should be that, then actually, then those vectors are coplanar. Got it, guys? Now here comes a very interesting statement. Two vectors are always coplanar. Now it might sound a bit skeptical, sir, ये कैसे हो गया? Okay, let me explain it. Let me use something to explain this. Okay, guys. So here I have a remote with me, and here is a pen. These are two vectors. Okay. Okay, guys, थोड़ा सा depth में visualize. Try to visualize it. See, if the vectors are like this, okay, and what I said, two vectors are always coplanar. Why they are coplanar? Because of the earlier property. We can always shift one of the vector, okay, so that it gets into the plane of the other vector, like something like this. Okay. Are these two vectors coplanar? Right now, no sir, nahi dikh raha. But if I shift them like this, हाँ sir, अब चमका. Following it, guys? Okay. Just take two pens with you. You can do it with your two fingers also. Orient your fingers in any two direction. Initially, it will feel, no sir, alag alag plane hai. This is something like this. This is something like this. But if you shift them, and we have already learned that shifting a vector parallel to itself has no effect. So if we shift these two vectors, they become coplanar. So the actual condition of coplanar vectors is applicable for three or more vectors. Getting it, guys? दो vectors always coplanar, उसमें तो सोचना ही नहीं है. For three vectors, now it becomes a condition. Let's say two vectors are lying in this plane. If the third vector is the pen, okay. If the third vector also lies in this plane, then the three vectors will be coplanar. Okay, everyone following, guys? The condition of coplanar is quite important. So how do we define it? I have purposely not written it earlier because I want to explain it now. Okay, now what will be the condition? If the third vector lies in the plane, okay, first condition, either it directly lies in the plane or lies parallel to the plane containing the other two vectors, then these three vectors are said to be coplanar. Everyone following, guys? Okay, so first for two vectors you defined a particular plane. Now that third vector can lie, okay, let's say these are the two planes, these are the two vectors and I have a plane for them. This is the plane. Now if that third vector is lying parallel to the plane, it can lie either in the plane itself or it lies parallel to the plane. Then the three vectors will be coplanar. It is possible that this is the plane containing the two vectors, then the third vector is something like this. So even after shifting, it is not lying in the plane, then those vectors will be non-coplanar. Everyone following, guys? अभी तक का पूरा पार्ट जितना भी वेक्टर्स का पढ़ा है हमने, okay, what did we studied? First of all, vector quantities होती क्या है? Then we studied difference between scalar and vector, okay, representation of the vectors, and then we studied about types of vectors. In the types we discussed equal, opposite and coplanar vectors. This entire part, is it clear to all? Very good, guys. It's such a lovely part teaching you all. You all follow so well. Okay, so what we'll do is we'll end the session here itself. I'll give you time, go again, revise it, अच्छे से दिमाग में उतार लो, let it settle like a concrete, okay, and then once the foundation is ready, we'll build upon it. Okay, guys, so it was lovely interacting with you all. Hope you all enjoyed a lot. Okay, there are coming topic, I mean the vector is not yet over, picture abhi baki hai mere dost. Okay, but we'll be learning in the coming sessions. So whatever be your comments regarding this session, मजा आया, बिल्कुल मजा नहीं आया, सर बोर हो गए, नींद आ गई, okay, whatever be it, please comment. I would love to see it all. Okay guys, this is Gaurang Sir, signing off. Take care.